Hello everyone, hope you are all fine. Today I am going to explain about composite numbers and its prime factorization. So in this topic, the most important things are that you must know about prime numbers and you must know about composite numbers. So first you must know what is prime number. See the prime numbers, the numbers having exactly two factors, that is the number 1 and itself. The number having the factors 1 and itself are known as prime numbers. For example, the smallest prime number is 2. The next will come 3, next 5, next 7, etc. Where two factors are 1 and 2 itself. 3 factors are 1 and 3 itself. 5 factors are 1 and 5 itself. 7 factors are 1 and 7 itself. That means these numbers are divisible by 1 in itself, and this type of numbers are known as prime numbers. After 7, next will come here 11, next 13, like that. So this type of numbers having exactly two factors 1 in itself are known as prime numbers. And next one is here the composite numbers, and composite numbers are the numbers having more than two factors. See, every number having at least two factors 1 in itself, and apart from 1 in itself, if a number having other factors, then the numbers are known as composite numbers. So that's why the definition of composite numbers is that the numbers having more than two factors are composite numbers. That means factors other than 1 itself. Like for example, the smallest composite number is here 4, and the factors of 4 are 1. Factors means by what numbers a given number is divisible. Those are called factors of that number. See, this 4 is divisible by 1, 4 divisible by 2, 4 divisible by 4. So this 4 is having three factors 1, 2 and 4. So as the number having more than two factors, it is composite number. Next is 6. 6 is divisible by what numbers? 6 divisible by 1, by 2, by 3 and by 6. So this 6 is having four factors 1, 2, 3 and 6. Therefore this 6 is a composite number. Like this, these are all composite numbers because they are having more than two factors. Okay, after composite numbers, then will come prime factorization. So what is prime factorization? See, number 6, I can write 2 into 3, and 6 I can write as 1 into 6, and 6 I can write as 1 into 2 into 3. So 6 can be expressed in terms of three expressions where the numbers are connected with product symbol, multiplication symbol. So these 2, 3, 1, 6, 1, 2, 3, these are all the factors of 6. So 6 is expressed in terms of its factors in product. So all these expressions are the factorization of 6. So for all this factorization of 6, see, this is a special factorization. In this factorization, you see each and every number is a prime number, or each and every number is a prime factor. So this factorization is known as prime factorization. This 1 into 6 also factorization of 6. 1, 2, 3 is also factorization of 6. But this factorization is known as the prime factorization of 6. And you cannot find any prime factorization of 6 other than 2 into 3. So for 6, this prime factorization is unique. These factors may change their place. 6 can be written as 3 into 2 also. Factors may change their place. That is not the main problem, but main thing is that the factors must be prime factor. Wherever factors are placed, no matter. If the factors are all prime factors, then it is known as prime factorization. And which is unique? This factor is unique for 6. And then next you take 12. The number is having many factorizations, but if you write a prime factorization of 12, it will be 2 into 2 into 3. So this prime factorization you can write 2 into 3 into 2 also, or this prime factorization of 12 you can write 3 into 2 into 2 also, no matter where you are putting the prime factors. But most important thing is that all the factors are prime factor. That's why this factorization is known as prime factorization of 12. And no one will get any prime factorization of 12 other than this. So this prime factorization of 12 is also unique for 12. That's why one very important theorem. The theorem is in the page number 8 of your textbook and it is marked at theorem 1.2. The theorem is that every composite number, here for example I have shown you 6, I have shown you 12, these are all composite numbers. So every composite number can be expressed or factorized as a product of primes. That means every composite numbers will have prime factorization, and this factorization is unique. That means every composite number must have prime factorization, and that prime factorization should be always unique for that composite number. And here it is given that apart from the order in which the prime factors occur. Okay, where you place the prime factors no matter, but thing is that they must be prime number, and that is called the prime factorization of that number. So this theorem is known as fundamental theorem of arithmetic. You write here fundamental theorem of arithmetic. So every composite number must have prime factorization, and that prime factorization is always unique. And so from here two things are clear, that prime factorization will come from the composite number only. Only composite numbers can give prime factorization, and that should be always unique. So what about then your prime numbers? The prime numbers are also factorization, but those are not prime factorization. For example, you see, take the prime number 3, and its factorization is only 1 into 3. And here in the factorization of 3, that is 1 into 3, 3 is a prime number, but this 1 is neither prime nor composite. So as 1 is not a prime number, so this 1 into 3 is not a prime factorization of 3. No doubt it is a factorization of 3, but it is not a prime factorization of 3. And here 3 is a prime number. So we have understood that the prime numbers are not having prime factorization. Only the composite numbers are having prime factorization, and that should be always unique for that particular composite number. Okay, now example, if I give you the number 72 and you are asked to find the prime factorization of 72, so what you'll do, start dividing like this. Start by the prime number. Always you have to divide the prime number. 2 into 36, then 2 into 18, 2 into 9, and then 3 into 3. So therefore prime factorization of 72 is 2 into 2 into 2 into 3 into. So this is the prime factorization of 72. So you have understood prime factorization. The next, HCF and LCM of numbers by using the prime factorization. Question is that find HCF and LCM of, you see here, 28 and 72. Solution. Okay, the solution also in the next page. Numbers are 28 and 72. So 28 prime factorization, you take 2 into 14, 27, and 72, 2, 36, 2, 18, 2, 9, 3, 3. So therefore 28 is here, 2 square into 7, and 72 is here, 2 cube into 3 square. So therefore HCF is, for HCF you have to use the common factor with the lowest power in the numbers. Common factors with the lowest power in both the numbers. In both the numbers common factors are 2 and nothing else. So the common factor is 2 only and the lowest power is square. So you have to take only 2 square, that is 4. Then the rule is that the common factors in the numbers having lowest power, the common factors in the numbers having lowest power, and LCM will be 2 into 3 into 7. That means for LCM you have to write all the factors in both the numbers. The two numbers are 28 and 72. In both the numbers, whatever factors are coming, all the factors you write. In both the numbers you see 2 is there, 3 is there, 7 is there. So write all 2, 3 and 7. And after that you have to put their highest power of all the factors. For the factor 2, what is the highest power here? For the factor 2, highest power is 3. Put here 3. Then for the number 3, only 3 is there, power 2. So highest power will be 2 only. The 3 power will be 2, 3 square. Then 7 is only single 7. The power is 1. 7 power will be 1. So this is the LCM. And here rule is that all the factors in the numbers having highest powers. Sorry. So here this will be your 8 and your 9. 9 is 72 into 7. 41. It will be 504. So in that way you can find the HCF and LCM of the numbers using the prime factorization. Next one important formula is that formula. For any two numbers comma HCF into LCM equal to product of the two numbers. For any two numbers, which you can use with the help of the previous example. So here verification numbers you take 28 and 72. Already HCF you have got. Are the two numbers, and their HCF is 4, LCM is 504. Therefore HCF into LCM, left hand side we take out the value 4 into 504, so it will be 2016. Now right hand side product of the two numbers, that also take product of the two numbers. The product of the two numbers will come here, 28 into 72. To multiply here 28 into 72, 16, 5, 6, 9, 6, 1, 0, 2, 2016. So here see, for these two numbers, these results I verified by using the two numbers 28 and 72. For these two numbers HCF already I've got 4, LCM is 504. Now left hand side I have written HCF in LCM, it is coming here 2016. Right hand side product of the two numbers, that means 28 into 72, that is also coming 2016. Therefore HCF into LCM equal to product of the two numbers. So it is verified. So this is a very important property. You have already got this in your junior class. Then from a textbook, one question is there. Question is that, question number 4, exercise 1.2. Given that HCF of two numbers are 306 and 657, 9. Find LCM of 306 and 657. So two numbers are given, HCF is given, the two numbers are given, you have to find the LCM. So you apply the formula. We know that HCF into LCM equal product of two numbers. HCF is your 9, LCM is unknown. Product of two numbers 306 into 657. Therefore, LCM equal to 306 into 657 by 9. Cancel it. 9 3 are 27, 3 left 36, 9 4 are 36. So LCM is 657 into 34, 4 7 are 28, 2 left 20, 22, 2 left 26, and 3 7 21, 6 17, 19, 8 3, 3 2 2. It is 2 2 3 3 8. That is LCM. I can use. We have got LCM by using the formula HCF into LCM equal to product of the two numbers. Now, so write one note. HCF of two numbers having common factor 1 is 1. Then LCM of two numbers having common factor 1 is the product of the two numbers. So this much for today. So today I have learned about prime number, composite number, and about the prime factorization of composite numbers. So you have to remember that only the composite numbers are having prime factorization and prime numbers are not having prime factorization. The very interesting property. Prime numbers are not having prime factorization, but composite numbers are only having prime factorization, and that prime factorization for any composite number is always unique. And after that you have learned how to find LCM and HCF by using the prime factorization. And the next class we'll do few extra questions based on the prime factorization of composite numbers, and after that we'll move to the irrational numbers. So thank you very much and have a nice day. See you in the next class.